into different constellations. So how far is the next nearest star? The trick question, of course, is what's the nearest star? And most people go Alpha Centauri. No, it's the Sun. The Sun. The closest nighttime star is the Alpha Centauri system, because the Sun can't be a nighttime star by definition, because the Sun is never up at nighttime. So the nearest star is the Sun. The nearest nighttime star, or next nearest, is the Alpha Centauri system. And Alpha Centauri, though, is sort of pretty low this time of year. It's sort of down there. It's really a winter thing. So in the middle of the winter, you see the Southern Cross up high. At the moment, the Southern Cross is turned upside down, and you can't really see it from here because we've got all these trees across here. So it's a bit hard to see Alpha Centauri. And Proxima Centauri, which the person mentioned before, is actually the closest, just by a tad, just a little bit, because there's actually 3 stars in the Alpha Centauri system. And when you see Alpha and Beta, these are the 2 pointers, Proxima Centauri is approximately here. It makes sort of a right-angled triangle, if you like. But you can't see it, even with the telescopes out there, they're not big enough to see Proxima Centauri. Very, very dim star. So you need a very big telescope and you need to know exactly where it is. And it's just a boring, very, very dim red star. But Alpha Centauri, the system Alpha Centauri, is the next closest star. It's about 4.4 light years. So light takes 4.4 years to get here. Or 44 trillion kilometres. So that's 44,000 billion. Or 44 million kilometres. To give you a scale, light from the Sun takes 8 minutes, which is 15 millionths of a year. So the Sun is 15 micro light years away, and Alpha Centauri is 4.4 light years away. So that's putting them in the same scale, light years. 15 millionths of a light year from the Sun. If you were to get in your car and drive to Alpha Centauri at 100 kilometres per hour and you didn't stop, it would take you 50 million years to get there. If you can get about 10 litres to the 100 kilometre, which you probably can, because you're going such a long distance, as long as you get the windows wound up, it will consume 1.8 million Olympic swimming pools of petrol to get there. That's the total oil production of the world in 1 year. So all the oil, all the petrol we make on the earth in every single country, all the petrol they consume in Europe and America and Australia and Asia, everywhere, is enough petrol to drive one car to Alpha Centauri in 50 million years' time. But all is not lost, because if you save your 4-cent dockets, the total fuel cost would be, yeah, the 8-cent dockets you'll save even more money. You wait till you see how much money you save. Right, it'll cost you about $6 trillion to fill this little car up in petrol. And you'll have to fill up 75 billion times. Imagine the number of chocolate bars you'll buy from the service station when they ask you, do you want a chocolate bar? You'd probably end up with 75 billion chocolate bars as well. But with your 4-cent docket, and if you had an 8-cent docket, you'd save twice as much. You'd save $180 billion just by using your 4-cent dockets. 360 billion if you had an 8-cent docket. So you could save a fortune. And when you get there, you'll actually see that Alpha Centauri, you'll see there's 2 stars. You won't see Proxima because it's way, way, way off to the side. It's actually made of 2 stars. One's a little bigger than our Sun, one's a little bit smaller. And the distance, you won't see it through a telescope tonight, unfortunately, because as I said, it's down below the trees. But if you come down here in the winter, it'll be nice and high, and there's bound to be someone who'll have Alpha Centauri in their telescope. When you look at it, you'll see 2 stars very close together. And one will look just a little bit dimmer than the other. So it'll look like 2 car headlights with one a little bit out of adjustment. So there's actually 2 stars there, and the distance between them is about the same distance as from our Sun to the planet Neptune, apart. And they take about 80 years to orbit each other. So these two stars are orbiting each other every 80 years. They have been for billions of years. Now if you look out at night, you would have noticed some stars have colours. Particularly you'll see Orion come out over there tonight when you go out there. And you'll see the familiar constellation, what we call the saucepan, which is actually part of a constellation called Orion. If we draw the lines in, you can see the saucepan shape, and you'll see that out there. Particularly, you'll see those three lines of stars. You can't miss it, they're quite bright. You'll see one star is a very bright blue, whitish colour. It's called Rigel. And that's a very big star, as you can see. It might be 780 light years away. Alpha Centauri is just over 4. But it's 66,000 times brighter than our Sun, which is why we can see it so bright from such a long distance. And it weighs 78 times what our star weighs. And if you look at Rigel through a telescope, and someone's bound to have Rigel there, you'll actually see there's another star close to Rigel, much, much dimmer. But that little dim star, if you do see it, is 2.5 times bigger than our Sun as well. And that'll just be this tiny little dim star next to a quite bright one. And the distance between those two stars is more than 2,000 times the distance between our Earth and the Sun. More than 2,000 times further. Pluto's only 38. Another one, so many people. Yeah.
With the stars, how do they determine how far they are?
If they're fairly close, like Alpha Centauri, they can measure what they call the parallax, which, like if you've got something and you look at it from one side or to the other, you can see it appears to move. But as it's further and further away, you can't see the parallax. But they can use other methods to determine how far, like they can estimate how bright it should be, and then they know how bright it is, so they can work out how far away it must be to be the brightness that it is, compared to what they know it is. Right, so they can do a whole heap of different methods. They can now measure them directly with that parallax to, I think, 1,000 light years or something like that. They've got what they call Hipparcos satellite up there, and that's just measured many, many thousands, tens of thousands of stars, very, very accurately. Plus or minus a few tens of billions of kilometres, but fairly accurately. Now another star a lot of people have heard the name of. It's probably got a dozen different ways to pronounce it. Betelgeuse, 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 Betelgeuse. Different ways, I don't know which one's exactly the right way, but it's a red colour, and you'll see it'll be out over there tonight. 640 light years, so around about the same distance as Rigel, but it's 135,000 times brighter than our star. Much, much brighter. It's nearly 1,000 times bigger. Betelgeuse is actually about the size of the orbit between the Sun and Mars. So if you were to plonk that star in the middle, Mars would be skirting around the outside of that star. We'd be inside it. So that's how big it is. It would stretch further than the whole orbit. You can see here, there's Rigel, there's Betelgeuse. Our Sun is basically 1 pixel. So the tiniest little dot on here, and that's how big Betelgeuse is at the same scale. You can see in Orion, all the main stars have names. Lots of things. Scientists like to name things. So those 3 stars in the belt, Mintaka, Alnilam and Alnitak, are the 3 ones in that belt which you see out over there. So they name them all. The other thing you'll notice when you look at that saucepan, there's a little fuzzy bit just on the corner where the handle joins to the saucepan. There's a fuzzy bit, and you'll notice it's fuzzy even with the naked eye. And if you look at that through a telescope, it's what they call the Orion Nebula. You won't see, what you'll actually see, there's 4 stars just in here. You'll see those 4 through the telescope. But the bit that you see in the eyepiece, you'll see this little bit here, and you'll see a few of these wisps. You won't see any of this whatsoever with your eye, because it's red and human eye is very insensitive to red. Virtually we're almost bordering on red blind. So when they take pictures with cameras, the cameras can see this red light that we can't see. So the colour is actually there. We just can't see it because we can't see red light. And we can't see most of the nebula. So when you see it tonight and see how big it is, the actual nebula is at least 4 times bigger than that. And if you can see red light, many, many times brighter. But you will see what they call the trapezium. So if you hear someone talk about the trapezium in Orion, this is the little bit that you'll be looking at through the eyepiece. And the eyepiece will probably cover about this much. And the whole thing is actually this much. Now you might think we can see millions of stars out there, and tonight hopefully we'll see a few. But you can only see about 3,500 stars with the naked eye in total, worldwide. About 60% of the stars are in the southern hemisphere, so we have more stars than what they have in the northern hemisphere, just don't tell them. So most of the stars visible with the naked eye are visible in the southern hemisphere. They're not visible from America or Europe. No, it just happens that the southern hemisphere points to a part of our galaxy that has more bright stars. There's actually lots of things we can see they can't see, just don't tell them, because they want to move here. So how big is our galaxy? It's about 100,000 light years across. So it takes light 100,000 years to travel from one end to the other. One thing you'll notice when you go out tonight, you'll see what appear to be 2 clouds. They're up about there somewhere. 2 smudges. And when you watch them, they won't appear to drift in the wind or anything. Through the night, they'll just gradually drift across. They're actually our 2 nearest large galaxies, what they call the Magellanic Clouds. And they're visible easily to the naked eye. I can even see them if I take my glasses off. I can't miss them. I just can't make anything out. But so tonight you can see, virtually guaranteed, you will see 2 galaxies with your naked eye. 2 big smudge patches, the large and small Magellanic Clouds. Yep.
On the telescope?
With the naked eye. When you walk out tonight, when your eyes adapt, look that way, you'll see 2 blurry things about there. They're galaxies. They're outside our galaxy. The small Magellanic Cloud, it's about 2 billion stars. So it's quite small. It's 200,000 light years away, so it's fairly close. If the moon was next to it, it's actually 6 times bigger than the moon appears to the naked eye, so it's quite a large smudge. The large Magellanic Cloud, it's got about 10 billion stars. And it's about 20 times larger than the moon. Similar distance, 160,000 light years. So you can see those tonight with the naked eye, you don't need a telescope. Someone is bound to put the telescopes, they'll probably have it on 47 Tucanae, which is right next to the small Magellanic Cloud, and the tarantula. The tarantula is actually part of the large Magellanic Cloud. And that's a large area, like the Orion Nebula, is forming stars. Big, big massive hydrogen gas. Now if we could see our galaxy, we can get far enough away. This is actually the Andromeda, which you can sort of see from the southern hemisphere, but it's very low. You can see it better in America because it's quite high, but you only barely see that with the naked eye. We can see 2 quite easily with the naked eye. You've got to have a very dark sight and pretty good night vision to see the Andromeda galaxy from the northern hemisphere. But our galaxy is a little bit smaller than that, so it's got 100 billion stars.